We're practically drowning in information these days. For any one thing, there are like a dozen competing explanations. So how in the world do you sort through all that noise to find what's actually true? Well, we're about to dive into a seriously powerful mental tool designed to do just that. It's a sharp principle for clear thinking.
So, get this. Picture it's the late 1800s. Astronomers are looking through their telescopes, and they see these faint, straight lines all over the surface of Mars. And the immediate, really exciting thought? Canals. They must have been built by intelligent Martians, right? But there was another possibility, that it was all just an optical illusion, a trick of the light playing on the human eye. So what do? How do you decide which one is more likely? This is exactly the kind of puzzle where you need a guide. And that guide? Well, it has a name. It's a principle that works kind of like a razor, designed to cut right through all the complexity and find the most direct path to the truth.
Okay, so officially, it's called Occam's razor. It's named after a philosopher from way back in the 14th century, William of Occam. And the core idea is actually pretty simple, but it's also incredibly profound. It just says that if you've got a bunch of different explanations and they all seem to fit the facts, the simplest one, the one that makes the fewest new, wild assumptions, that's probably the one you should go with. This is the classic way of putting it, a little more poetic, right? But what it's really saying is, hey, don't invent extra stuff. Don't add dragons or ghosts or secret alien civilizations to your explanation if you really, really don't have to. And that razor metaphor, it's just perfect. You're not uncovering some secret law of the universe. You're just using a tool. You're shaving off all the fuzzy, complicated, unnecessary assumptions, and what you're left with is the cleanest, most direct explanation that still fits all the evidence. Now, this isn't just some old-school philosophical preference for things looking neat. The whole idea gets a massive upgrade from modern math, specifically probability theory. It turns out simpler models are often statistically more likely to be right. Why? Because they don't spread their bets. They make really specific predictions. So when the data you see perfectly matches one of those sharp predictions, that simple model gets a huge boost in credibility. Okay, let me show you what I mean. Let's make this super concrete. Just look at these two frames. In the first one, you see a dot. In the second, you see a dot, but it's moved a little bit to the right. So what's the story here? Hypothesis A, it's one object and it just moved. Simple. Hypothesis B, the first object completely vanished, and then a brand new, totally separate object just happened to appear in a different spot. Both stories perfectly explain what you just saw, but which one does your brain instantly, automatically go with? Yeah, your brain and the math of probabilities screams that it's just one moving object. But why? Because that one object model is just simpler. It makes way fewer assumptions. The two objects model? Man, for that to be true, you have to assume that one object disappeared and that a new one appeared in just the right place at just the right time. The simpler model just makes more sense.
And believe me, this isn't just some neat little brain teaser. This way of thinking has been at the absolute heart of some of the biggest revolutions in the history of science.
For a really long time, scientists explained fire with something called phlogiston, this weird, invisible, fire-like element that was supposedly hidden inside things and got released when they burned. It got super complicated trying to make it all work. Then a guy named Antoine Lavoisier came along with a much simpler idea. Burning isn't about releasing something, it's about combining with something. Oxygen. It explained everything so much more cleanly. Occam's razor shaved phlogiston right out of the textbooks. You see the same thing in physics. For decades, scientists couldn't figure out how light could travel through the empty vacuum of space. So they invented this invisible, universe-filling jello called the luminiferous ether. It was a lot. Then Albert Einstein comes along. His theory of special relativity showed that if you just make one simple assumption, that the speed of light is always constant, poof, you don't need the ether at all. It was an extra, unnecessary part, and the razor just sliced it away. And to see how powerful this is, check out this wild example, the hollow Earth hypothesis. This is the idea that we actually live on the inside surface of a hollow planet. And believe it or not, you can actually make all the math and physics work, if you assume that space and time are warped in this incredibly specific and complicated way. But Occam's razor just steps in and asks, why? Why would you do that? This model adds a whole universe of bizarre, needless assumptions just to explain the exact same things that the simple we live on the outside model does. It's the perfect target for the razor. But, and this is a huge but, here's the twist. As powerful as the razor is, it's not foolproof. Actually, if you're not careful with it, you can get badly cut. Simplicity is a guide, but it is not always the destination.
So let me introduce you to the razor's evil twin, Occam's broom. This is what happens when you fall in love with your simple, tidy theory so much that you start sweeping any inconvenient facts right under the rug. It's an anti-thinking tool. You're actively ignoring evidence just to protect your simple explanation. So let's put them side by side to make it crystal clear. The razor cuts away needless assumptions to find a better theory. The broom sweeps away inconvenient facts to protect a favorite theory. One is a tool for finding the truth, the other is a tool for defending your own bias. And there's a formal counter-argument to this whole thing, sometimes called the anti-razor. It's basically a reminder that, hey, sometimes things really are complicated. You can't just oversimplify reality. If a problem genuinely needs a more complex explanation, then using a simple one isn't clever, it's just wrong. And maybe the greatest example of this in all of science is the story of the universe itself. The steady-state theory was way simpler. The universe has always been here, more or less the same. The Big Bang theory was more complex. It proposed a definite beginning and expansion from a single point. For a while, the simpler theories seemed way more elegant, but it had a huge problem. It just couldn't explain key pieces of evidence we were finding, like the faint radiation left over from the initial explosion. The more complex theory explained all the facts, and so it won. So where does that leave us? How do we use this double-edged sword without getting hurt? Well, we have to remember exactly what it is and what it isn't. Okay, this is absolutely crucial to get right. Occam's razor is not a law of nature. It doesn't command the universe to be simple. It's what's called a heuristic. It's a rule of thumb, an efficient search strategy. It guides us to start with the simplest explanations because, all things being equal, they're often the most probable. See, the real goal isn't just simplicity for simplicity's sake. The goal is the most powerful explanation. And that means finding the simplest theory that can do three things. It has to explain all the evidence, not just some of it. It has to have the power to make new predictions that we can go out and test. And maybe most importantly, there has to be a way to prove it wrong if it is wrong. Simplicity is just a tiebreaker, not the whole game. This all leads to a much more refined, modern idea called effective complexity. It suggests that true simplicity isn't about having fewer parts, it's about having a shorter, more powerful description. Think about it. A random string of letters is simple in one way, but its description is super long. You have to write out every letter. A crystal, on the other hand, is also simple, but its description is very short. Just repeat this basic structure over and over. The best theories are like that crystal. They have a really concise model that explains a huge amount of stuff. And this leaves us with a final, really challenging question that gets right to the heart of what simplicity actually means. When we try to explain all the amazing diversity of life on Earth, which explanation is truly simpler? Is it a theory that adds a brand new, incredibly complex entity, an intelligent designer that doesn't follow any known rules? Or is it a theory like natural selection, which uses the rules we already have, like inheritance and environment, and just lets them play out in complex ways over a very long time? The razor asks us to look beyond the surface and figure out which model gives us the most explanatory power for the fewest new assumptions. And that is a question worth thinking about.